(-1 to the n plus 1 power times 1 over n). First of all, is this an alternating series? Oh my gosh, it's the most obvious thing. You got that right there, it's an alternating series. Now, what's a sub n though? Need to identify. No, don't, it's not a p series. What is the a sub n term?
1 over n.
Right, okay. I'm telling you, identify it when it's easy so that when it's hard, you know to do it. Okay? Now, the alternating series test says I must do two things. I must test the limit as n goes to infinity of 1 over n. Is that equal to 0? Yes, of course.
Yes.
Yes, okay, fine, check. Then I have to evaluate this statement. I have to take the n plus 1th term, which would be just 1 over n plus 1. And I have to see if that term is always going to be less than or equal to 1 over n, which is a sub n. Is that statement always true?
Yes.
Yes, it is. Because the first denominator is always going to be larger than the second one, therefore that number is always going to be slightly smaller than this one. Check. Now both conditions are met. And the rule is an alternating series
Converges.
converges. Okay, here's the deal. An alternating series only ever tells us convergence. So if the alternating series works, guaranteed convergence. So, right here, by the alternating series test, series converges. Okay? All right. Now I'm going to give you one that's a little bit more of a challenge because the a sub n term is not immediately obvious. Okay? So if you suspect that it is an alternating series, you will have to make it match what an alternating series should look like. Okay? So, example. Converge or diverge. Sum n equals 1 to infinity. N divided by -2 to the n minus 1 power. Are those terms going to alternate sign?
Yeah.
Yes. Because every time n is odd, I get an even power, right?
Every time n is odd, it'll be positive, and every time n is odd, it'll be negative.
Right. So will this series alternate?
Yes.
But here's the problem. It is not in the alternating series form. I need this to look like -1, probably to the n minus 1 power, times a sub n. Now the power, I'm stuck with. So I need to make this look like it should.
Can you factor out the 2? Or can you factor out a 1/2? Oh no, we can't actually, because the base
See, I
isn't.
don't want to factor out a 1/2. What did I factor out last time? What did I factor out right here? The -1, right? So I just need to do the same thing. That's all. Now, the fact that the -1 is in the denominator doesn't mean anything. Right? Because what's 1 over -1? It's still -1. So in this case, although it may look weird, it's actually quite simple because what's my denominator? It's -1 times 2, right? And can I not use that same exponent property by splitting the bases? Both to the same exponent? So -1 to the n minus 1 times 2 to the n minus 1. Same thing. So, now my denominator is 2 to the n minus 1. And this is -1 to the n minus 1. What's my a sub n?
N over 2 n to
Yes.
N over
And
2.
a sub n is going to be n divided by 2 to the n minus 1 power. Okay. Now, let's apply the tests. Limit n to infinity of n over 2 to the n minus 1 power. Is that going to go to 0?
Yes.
Let me remind you, I'm dividing a polynomial by a faster growing function exponential.
So yes.
Clearly, yes. Clearly, yes. Now, what is the n plus 1th term?
One half n minus 1.
Too complicated. What was the last, what does it mean if I'm going to take a sub n and replace it with a sub n plus 1? What am I really doing? No. If I ask you to do that and then I do this instead, what am I doing? Let's say that I have x squared plus 3. What's this? Or let's go easier. What's this? I don't want the number, I want to know what to do with it.
The value you plug in as x.
So you're telling me that the letter x has been replaced with the number 3? And I want to replace every x over here with that number 3? Okay. Now what if I replace x with x plus 1?
Replace every x with x plus 1.
Replace every x with x plus 1. Okay, fine. Now, how do I do n plus 1? A to the n plus, or a sub n plus 1. Replace every n with n plus 1. Now I have 2 to the n plus 1 minus 1.
2 to the n.
Yep. And that is supposed to be less than or equal to the actual a sub n. And notice I do want to see that work exactly as that inequality is written. And then I need you to evaluate whether or not that's true.
It's
The numerators are practically the same. Which denominator is always going to be larger?
2 to the n.
The left one, of course. Because that 2 is always going to have a power 1 higher than the one on this side. So which denominator is always going to be larger? 2 to the n. Therefore, creating a smaller number. So, and I know I've got a plus 1 up here, which is a little bit bigger than this. But as n goes to infinity, that doesn't matter. Okay? So 7 over 2 to the 6th would be less than 6 over 2 to the 5th. Much less, actually. So, check, check. What's my conclusion?
Converges by
How did I write the last one?
AST series converges.
By alternating series, test, series, convergence. Okay, let's do one more. Example. Converge or diverge, sum n equals 1 to infinity, negative 1 to the n plus 1 power, times n plus 1, all divided by n. Alternating series?
Yes.
Absolutely. Okay? Stands out like a sour note in a madrigal.
Well, I know what you're talking about. I get the reference.
All right. So what's a sub n?
n plus one over n?
Yep, n plus 1 over n. And it might not be a bad idea to annotate that just to make sure that you are right. I'd hate to see something obvious and then, that it's obviously alternating series test, and then all of a sudden realize I never did get the right series. Okay, so what do you do?
Limit n approaches infinity
Right.
of a sub n.
Which is n plus 1 over n.
You get infinity of infinity,
Right?
so
So I can do Hopital's,
then you get 1 over 1,
which is,
1,
what am I supposed to be getting?
anything other than 0.
No.
Oh.
Alternating series test requires that the limit of a sub n is equal to 0. So actually, how about I write it this way? So what's my conclusion?
Diverges by AC.
Well, my diverges by AST never will be said. Because the alternating, you're right, alternating series test never shows divergence,
Oh,
okay?
by failure of AST.
Ah, well, it fails that test. No. So it fails alternating series test. But in doing so, it passes
The nth term test.
the divergence test, correct?
So by divergence test,
Yes.
series diverges.
Yes. Okay, so therefore, and why don't we be specific, because these are our notes. AST fails, but by the divergence test, if you want to call it that, series diverges. You see why, right?
I think Leanne sees why.
Terms are growing. The terms are getting bigger. Now, what is the one thing that is, let's go back. What is the one thing that is true for every single convergent series?
They'll approach 0.
The what? The terms decrease. Yes, the terms decrease. The terms here do not decrease. They do get closer and closer to 1, but they're not decreasing. Okay? You see that?
They'd be actually increasing ever so slightly.
But the sum would be increasing considerably, actually. Basically, it's just 1 plus 1, 1, 1, 1, that goes to infinity, so it diverges. The terms have to decrease. That is the one thing that is consistent of every single convergent series.